The first of these jet streams is called the subtropical jet. We know it's created by massive temperature differences, but what's its cause of this temperature difference? If you remember from earlier lessons, we identified large global circulations of air. The heat generated near the equator starts the first two air circulation cells. These are called the Hadley cells. The next two cells circulating either side of the Hadley cells are called the Ferrel cells. These cells have much cooler air circulation since they are at higher latitudes. Lastly, the cells circulating near as the poles are the coldest and are called polar cells. Remember, we need a large temperature difference for a jet to form. If you look here and here, between the Ferrel and Hadley cells, there is a junction of warm and cold air. This is where the subtropical jet streams are found. Notice that the subtropical jets are westerly. Looking at the one in the northern hemisphere, you can see that with your back to the wind, the cold air is to the left. However, in the southern hemisphere, the cold air is to your right. Always use these laws to help confirm upper wind directions. There is more to understand about these particular jet streams though. On average, these jets are found between 20 and 40 degrees latitude. However, they move north and south with the seasons. If we consider the picture to be for March, let's look at the diagram to see what happens. Going into July, notice that it's summer in the northern hemisphere and winter in the southern hemisphere. The jet stream in the northern hemisphere has moved north to approximately 40 degrees, whereas the jet stream in the southern hemisphere has moved to approximately 20 degrees. Let's now look at the change in December. This time it's summer in the southern hemisphere and winter in the northern hemisphere. A southern hemisphere jet has moved to 40 degrees and the northern hemisphere jet has moved to 20 degrees. In summary then, these jets move to lower latitudes in winter and higher latitudes in summer. They are permanent features across the Earth and are almost always westerly in direction. The subtropical jet streams are generally found at approximately 40,000 feet, roughly the 200 hectopascal level, but this will vary as the jets move north and south. Generally though, we can say that they will be lower in winter and higher in summer. Let's now examine the strength or the wind speed of these jets. Their average speed is approximately 80 to 150 knots, but this changes from season and location. In summer, the relative temperature difference between the equatorial air and temperate air is small, but in winter the temperature difference is much more pronounced. If you remember, the greater the temperature difference is, the greater the speed of the upper wind. So, in general, the speed of these jets gets faster in winter and slower in summer. The location also plays an important part. Have a look at the diagram. We have a picture of Southeast Asia in the winter. The subtropical jet stream in the northern hemisphere has moved down to 20 degrees north. However, the Asian landmass, and in particular the Tibetan plateau, has become very cold indeed. This increases the temperature difference even more, and on occasion the subtropical jet stream has been recorded at speeds of up to 400 knots. This is a rare situation, but it can happen. The subtropical jet needs to be closely watched in this area in winter. The next Temperature variation we can see on this global picture of air circulation is between the ferrule and polar cells, here and here. The surface feature between these two cells is the polar front, which in fact separates the cold polar maritime air and the warm tropical maritime air. We can see these two air masses converging and rising at the junction between the two cells. To find the direction, just use the laws we've already studied. In the northern hemisphere with your back to the wind, the cold polar maritime air will be on the left. Therefore, the polar front jet will run approximately westerly. In the southern hemisphere, the law says that with your back to the wind, the cold air is to the right. The polar front jet stream here will also be westerly. The diagram can look confusing, since we stated all jet streams are usually located in the warmer of the respective air masses, but it looks like the polar front jet stream is in fact in the polar maritime air. Remember though that the polar front boundary that you see is only the surface position, and the jet has been superimposed onto this surface position. If we were to take a cross-section of the polar front from here to there, you'll notice that the jet is in the warm tropical maritime air. Looking back to the global picture, we can see that the jet is very sinuous and reality, it is very disjointed and broken. However, its general area is said to be between 45 to 65 degrees north and south. In a similar manner to the subtropical jet stream, this jet stream will move north and south with the seasons, generally moving to 30 to 40 degrees in the winter and 50 to 60 degrees in summer. In the southern hemisphere, the movement is moderated by the sea, since there is very little land to disturb the temperature and wind patterns. Since this jet stream is found at higher latitude, we'd expect it to be at a slightly lower altitude than the subtropical jet stream. In fact, it's commonly found at about 30,000 feet, roughly the 300 hectopascal level. This level changes as the jets move north and south. Again, in winter, expect them to be at a slightly lower altitude than in summer. The average speeds are less than the subtropical jet, only about 80 to 130 knots. But similarly with the subtropical jet, the temperature variation between the polar maritime and tropical air masses are greater in winter, and as a result the jet will be faster and stronger, sometimes up to 200 knots or more. Another jet stream which can sometimes be observed is found whenever there are outbreaks of very cold Arctic air. The diagram here is concentrating on the northern hemisphere where this phenomenon occurs. Here you see a polar front depression, but more importantly, a back-bent occlusion. Looking along the line of the occlusion, you can see the isobars running from the Arctic towards the occlusion. The airflow will more or less follow this path towards the occlusion. This air is very cold, and it meets the relatively warmer polar maritime air at the point of the occlusion. This can be referred to as an Arctic front. In other words, a frontal boundary separating very cold Arctic air and warmer polar air. There can be enough of a temperature difference along this front to create a jet stream. This jet stream is called the Arctic front jet. It's only really found in the northern hemisphere and usually only during the winter months. The axis of the front is roughly from Iceland through to northern Norway, and as such the jet stream is located at approximately 60 degrees north. The Arctic front itself only reaches up to 10,000 feet. suggesting that the jet stream is only found just above this level, perhaps between 10,000 and 20,000 feet. The worst of the jet streams to consider is called the tropical easterly jet. It may sometimes be called the equatorial easterly jet, but this term can be misleading. The diagram here shows southern Asia in the summer period. Notice the ITCZ to the north of the equator confirming the northern hemisphere summer period. Of interest is the Tibetan Plateau shown here. It's a flat area at approximately 8,000 feet and is warmed significantly during the summer months. This creates a strong thermal effect. The land mass will be much warmer than the relatively cooler seas near the equator. This temperature difference is enough to generate a jet stream, but how will it flow? If you remember, the law stated that with your back to the wind in the northern hemisphere, the cold air is to the left. This means that the tropical easterly jet stream must be in an easterly direction between the cooler equatorial seas on the left and the warm Tibetan Plateau on the right. Please note, the tropical easterly jet only occurs in this location and from June through to August, which are the summer months in the northern hemisphere. On average, it's found between 5 and 20 degrees north only. Tropical easterly jet speeds are seldom in excess of 100 knots due to the fairly small temperature difference compared to other jet streams. Since the tropical easterly jet stream is so close to the equator, it's one of the highest tropospheric jets, approximately 40,000 to 45,000 feet, or roughly the 100 to 200 hectopascal levels. If you remember, at about this time of the year, the subtropical jet was found at about 40 degrees north, keeping the warm air from the Tibetan Plateau to the right and the cooler Siberian air to the left. However, during winter, this jet will move south and replace the tropical easterly jet. Over India, it's usual to find a complete reversal of the upper wind pattern from season to season. The diagram shown here summarizes the positions of the jet streams across the globe. But be wary. They do wander and can migrate significantly with the seasons. Remember the rules about where clear air turbulence is found around jet streams. In the northern hemisphere with your back to the jet stream, the cat is found facing the cold air. In other words, on your left. In the southern hemisphere with your back to the wind, the cat is again found facing the cold air, but this time to your right.